Today I wanted to talk about a problem that was on the homework that's due today, and it was number 5 I told you to skip. So there are two ways to do this problem. One way involves the use of two right triangles and then subtracting. The second way involves right triangle trigonometry and then also non-right triangle trigonometry using the law of sines. So first of all, let's talk about the problem. So it says, as part of their weather unit, Christy's science class took a hot air balloon ride. As they passed over a fenced field, the field is right there in the picture. As they passed over a fenced field, the angle of depression of the closer side of the fence was 32 degrees. So that's what I've drawn in yellow there. This angle right here is 32 degrees. The angle of depressions on the outside, it also matches the angle of elevation on the inside of the triangle. Again, that's the yellow triangle. And then the angle of depression to the farther side of the fence was 27 degrees. So from the hot air balloon to the farther side of the fence, this angle is 27, which means also this angle is 27. Okay, so for the first method here, the big right triangle minus the small right triangle is going to give us the length that we're looking for. So it said we are trying to figure out what is the width of the field. The x is what we're looking for. So we're using the big right triangle's side minus the small right triangle's side, which is here, and that will give us the x that we're looking for. So x is equal to p minus m. So in the yellow triangle, tangent 32 is equal to 800 over m, opposite over adjacent. And then in the red triangle, tangent 27 is 800 over p. So again, tangent's opposite over adjacent. And then once you solve for those two values, you can simply subtract them, and that will be the answer that you're looking for. Now, in the second method, we're going to use one right triangle and then one non-right triangle. So what I did is I noticed that in the little skinny triangle on the outside that is not a right triangle, I noticed that I went ahead and copied it over on the side over here. I noticed that if the angle here, that we're looking for x, okay, and we can find that angle up there because 32 minus 27 is 5 degrees. And then we have a 27 degree angle down here because it was alternate interior with the one angle of depression. So if we do right triangle trig and calculate this length, that would be this side of the non-right triangle, then we would be able to do law of sines to figure out the x that we would need, because we have, when we're looking for a law of sines here, we have the sine of an angle over its opposite side equals the sine of an angle over its opposite side. So we're going to do right triangle trigonometry. That's going to be sine this time. The sine of 32 is equal to opposite y over opposite 800 over the hypotenuse y. Solve that. And then for the second problem, now that we know that y is 1509.7, we can do the law of sines, and then it's going to give us the same answer as what we got the other method. So anytime you have a non-right triangle, try to figure out what you know about that non-right triangle. This particular problem could have been done either of these ways. Sometimes when the diagram involves a non-right triangle, the only way to do it is with non-right triangle trig. That means law of sines or law of cosines.